Assalamualaikum and hi everyone. This is a video about 3D mapping of magnetic field for our second mini project. Okay, this is list of our group members. First, Muhammad IZZUDIN bin Ahmad SHAFI, me Nur AMIRA ASYIKIN binti SHAMSUDDIN, and FARID bin Muhammad ZAKARIA.
Okay, the objective of this experiment is to plot and visualize the 3D pattern of the magnetic field of a better magnet, and the second objective is to analyze the magnetic field properties and create a 3D map of magnetic field strength around the better magnet, and the last objective is to study the magnitude of the magnetic field at various points around the button magnet using a Hall effect sensor. Okay, for this part, which is introduction, what is 3D mapping of magnetic field? The magnetic field is the process of creating a three-dimensional representation of magnetic field in a particular region. Okay, for the second point is involve measuring the magnetic field strength and direction, and Hall effect sensor are devices used to measure the magnetic field strength by taking measurement at different locations within area. Okay, for literature review, the first review different measurement technique used in 3D mapping of magnetic field, and the second discuss the principle of operation, advantages, limitation, and application, and the third discuss approach for addressing data outlier and errors during processing, and the fourth review visualization technique used to present 3D magnetic field maps, and the last point, which is identify the current challenges and limitation in 3D mapping of magnetic field. Okay, for this part, which is problem statement, for the first problem statement is measurement accuracy and instrumentation. Another critical aspect is ensuring accurate measurement of magnetic field strength and direction. The choice of suitable magnetometer, recalibration, and the minimization of instrument related error are crucial factor in obtaining reliable and precise data. And the second point is data collection efficiency. Maximizing data collection efficiency is important to minimize time, effort, and cost. For data processing and interpolation, which is the processing and interpolation of collected magnetic field data, present challenges, particularly when dealing with sparse or irregular distributed measurement. And the last point, which is visualization and interpretation, which is effectively visualizing and interpreting the 3D magnetic field map require appropriate software, tools, and technique.
This is apparatus that we use in our experiment, which are Arduino Uno, Hall effect sensors, holder of Hall effect sensors, PVC tape, button magnets, jumper wires, breadboard, scale graph paper, and retort stand. Okay, this is our procedure for calibration process. We make comparison between the application in the phone app and also using the NetBean project. First, the magnetic field application is run on the phone. Then a button magnet is attached near the phone to detect the magnetic field of the magnets. Then we record the value of the magnetic field observed from the application, and we repeat it with different number of magnets. But we need to make sure that the distance between the sensor and the magnet is same between two applications. For the NetBean project, we prepared a NetBean project with magnetic field interfacing, and we run it with the button magnets attached to the Hall effect sensors. Then we record the voltage output and magnetic field observed from the project. We also repeated the step using different number of magnets. Then data is tabulated in the table 1, and the calibration graph is plotted using GNU plot. A fixed equation of the calibration function is also obtained.
The procedure of the experiment. So for the first step, we write a suitable program for the Arduino to read and record the value measured by the Hall effect sensor. Then the next step is we arrange the Hall effect sensor. We use three Hall effect sensor and we position it to perpendicular to each other and then connected to the Arduino. The Arduino later are connected to the laptop. The next step is the button magnet that we use, we place on a marked graph paper, and then the graph paper are placed on a flat surface. And we must ensure that the surface or the platform we use are non-magnetic platform and have a upper level and lower level since we want to calculate the magnetic field. The next step is the Hall effect sensor is moved along the x-axis and y-axis coordinate that are marked on the graph paper. Then the step number 5, we repeat the previous step, which is step number 4, for the upper level of the platform and the lower level of the platform. And then step number 6, the result that we get, we we tabulate it, and later we plot a 3D graph of the magnetic field from the result. The figure shows the upper view and the side view of the arrangement of the apparatus that we use for this experiment.
Okay, this is our result and analysis part. For calibration, we use 6 button magnets. Then we record the voltage value and magnetic field value when we using Hall effect sensor and the phone app. After that, we plot the calibration graph using GNU plot. As we can see, the graph linearly increase according to the table and figure with the value of magnetic field measured using the Hall effect sensor and smartphone app are very close to each other. The fitting equation for both data are fx equal to 139.39 x minus 216.9. The data obtained from Hall effect sensor are said to be reliable.
For the next part is result analysis of the experiment. So from the experiment, we get the result of the magnetic field and the voltage. So the result of voltage and magnetic field are from three different sensors, which is the x-axis, y-axis, and z-axis for each coordinate. So the table show each axis of the magnetic field for one coordinate and so on. So these two tables show some of the value, the result that we get from the experiment. From the result of our experiment, we plot a 3D graph of magnetic field of the button magnet. So from the graph shown, the graph itself shows the shape of the magnetic field of the button magnet, and there are larger and bigger arrow compared to the smaller one, and the bigger one means that there are strong magnetic field at that coordinate. So we can see that the further away the sensor from the magnetic field, the smaller the value that we measured, and the direction of the arrow represent the resultant magnetic force or resultant magnetic field at that coordinate. This graph shows the basic shape of the north pole and the south pole of the magnetic field of the button effect. So we can see from the graph, the arrow of the upper level shows toward the north, while the lower level shows toward the south. So it's basically similar to the theoretical magnetic field of a magnet. For the discussion of this experiment, we can see that the higher the value of magnetic field measured by the Hall effect sensor, the longer the length of the arrow plotted on the graph. So we conclude that the higher value we get from the result, the longer the length of the arrow plotted. when we see the graph of the magnetic field, we see at the outer layer they got a small arrow, which is some are short and some are very small. So we conclude that at the outer level of the magnetic field, there are very few, not very few, but a very small value of the magnetic field that can be measured. Unfortunately, from this experiment, we can also see the lower part of the graph. The length of the arrow is differ by much. Why is this so? This probably error because of the experiment that we conduct for the upper level and the lower level at certain time interval. And then the second maybe because of the assembly and the disassemble of the circuit that we have connected already. So it's probably disoriented, and the button magnet probably damaged. So to prevent this error, we should conduct the experiment and conclude the experiment in the very first time we tried, so that there is no effect for the circuit or button magnet to be damaged. And secondly, for precaution, we can keep the circuit as it is after we done the experiment, so that the Hall effect sensor won't be damaged because we disassemble and assemble it again.
Next, for the conclusion part, the magnetic field of button magnets in three dimensions is studied using three Hall effect sensors. The magnetic field pattern above the button magnet spread out in positive direction at positive X and Y position and negative direction at negative and Y position. The magnetic field strength of buttons magnets is decreases when the distance from the source of magnet is increases. The objective in this project is achieved. That's all from us. Thank you for watching.